Aim of this practical is to understand different components of air conditioning test rig and determine its COP. So here this is a setup of air conditioning test rig. These are the different components. Here you can see that this is our compressor where the refrigerant is compressed and moving further to the condenser. This is our condenser where refrigerant reject the heat to the atmosphere. This is our expansion valve and the dryer. This is our pressure gauge. This is temperature indicator. And this is our humidifier from where steam is generated. This is the 4 input which we can give to this setup. The first one is AHU, which is air handling unit. The second one is for the compressor. The third one is the heater, and the last one is for the humidifier. So in this setup we can do 4 practicals. First one is for the sensible cooling. The second one is for the sensible heating. Third one is for this cooling with humidification, and the last one is for the heating and the humidification. If we give input only for the compressor, so if we only switch on the compressor switch and air handling unit switch, then the sensible cooling will happen. If with cooling, so that with compressor, if we switch on the humidifier, then the apparatus perform cooling with humidification. Similarly, if we give input only for the heater, then sensible heating will take place, and with heater, if we switch on the humidifier, then heating with humidification will happen. So now first we find out the COP of this apparatus. Then we will perform different psychrometric process like sensible cooling, sensible heating, cooling with humidification, and heating with humidification. So first switch on the apparatus main switch. Now for the finding out the COP, we will start the air handling unit as well as compressor. So the refrigerant will flow from the compressor to the condenser, then it will go for the expansion valve and then in the evaporator zone. Here this is our compressor, this is condenser, this is dryer and the evaporator section, expansion section. This is our evaporator section from where the air is flowing. This is the air inlet. In this duct, through this duct, air is going into this duct. At the center portion, the refrigeration or heating effect will take place, and the cold air or hot air will coming out from this air outlet. So this is pressure gauges. From these 2 pressure gauges we can measure the pressure. This is the temperature indicator from where we can take readings of the temperature for the after compression, after condensation, after expansion and after the evaporation. This is dehumidifier. This is inlet valve of the dehumidifier from where the water, we can pour the water into dehumidifier. This is the heater for the sensible heating process. These are the pressure gauges from where we can get reading of the suction and discharge pressure. This is a meter which shows the amount of work done, actual work done given to the compressor, which shows 3200 pulses per kilowatt hour. So from this reading we can calculate the practical work done given to the compressor. Now after some time we can take reading of the DW, wet bulb temperature, DBT, WBT and dry bulb temperature with the help of sling psychrometer. This is a sling psychrometer. By using this psychrometer we can measure WBT and DBT of the inlet condition as well as outlet condition. So this is how we can take reading of dBT and WBT for the air inlet. Same procedure for the air outlet. So with the help of this sling psychrometer, we will get dBT, WBT for the both condition, inlet and the outlet. By using this flow meter, anemometer, we can calculate the velocity of the air in meter per second. So this is how we will get the velocity of the air by using this flow meter. Let's do calculation for the practical. Now let's do calculation. Here we have air inlet temperature which is 24 degrees Celsius, air outlet temperature which is 17 degrees Celsius. These two temperatures are the dry bulb temperature. The air velocity is 3 meter per second. So cooling effect, actual cooling will be calculated by mCp delta T, amount of heat which is rejected by the air to the refrigerant. So where here m is a flow rate of the air. So we have the velocity of the air. So by using rho AV, density into area of the duct into velocity of the air, we can calculate the flow rate of the air in kg per second. Cp is a specific heat of air which is 1.005 kilojoule per kg Kelvin, and delta T is a temperature difference of inlet air and the outlet air. So putting the value in this equation, we will get the Re actual which is 1.29 kilowatt. Now actual work done given to the compressor can be calculated by the reading from the meter for the 10 second. So for the 10 second we can calculate the work done by using this 10 into 3600 divided by 3200 into T. So by putting value in this equation, we will get actual work done as a 0.536. So COP can be calculated as actual refrigeration divided by actual work done. So we will get actual COP which is 2.41. Now let's calculate theoretical COP. So for theoretical COP we required two pressure ranges. So from the pressure gauge reading we have suction pressure as well as discharge pressure. So by using these two value, we can locate the 4 points on the pH chart of the refrigerant 134A. From that 4 points we will get the values of enthalpy at that 4 points, H1, H2, H3 and H4. From this value we know that the refrigeration occurs in the evaporator which is between H1 and H4. So H1 minus H4 will give us a refrigeration effect. The work given to the compressor, so the compressor is between 1 and 2, so H2 minus H1 will give the work done given to the compressor. So theoretical COP would be H1 minus H4 upon H2 minus H1. So we will get theoretical COP as a 3.5. So this is how we can calculate the COP, theoretical COP as well as practical COP or actual COP of the air conditioning test rig.